Okay, 9.4, solving log equations. So these are the steps. Basically, you have to condense it. So you have to get it down to one logarithm. Use the one-to-one property. So that means if log base b of m equals log base b of n, then m equals n. So you can drop the logs and set the insides equal to each other. Then we have to solve and check for extraneous solutions. That just means extraneous solutions. You cannot have a negative number in a logarithm. So we have to go double check that whatever our solution is, when we plug it in, it's not going to give us a negative. Okay, so let's look at this one. So we have log base 5 of 5x plus 9 equals log base 5 of 6x. Well, those are already condensed. We can drop those logs right there, and you have 5x plus 9 equals 6x. Solve that for x, and you get x equals 9. We just have to check for extraneous solutions, so I'm going to plug it in to make sure I don't have a negative in the logarithm. So 5 times 9 plus 9, that equals 54, which is non-negative. And then 6 times 9 is a 54 also, so I don't get any negatives out of there, so x equals 9 is my answer. Okay, let's look at this one. So we have log of 4, or y plus 4 plus log of 4 equals log of 72. Well, let's condense them, so we just have one log on both sides. Addition goes with multiplication, so that's going to be log of 4 times y plus 4 equals log of 72. So that's 4y plus 16 equals log of 72. Now you can drop those logs, and you get 4y plus 16 equals 72. Subtract the 16 over, 4y equals 56. Divide by 4, so you get y equals 14. Now we have to check for extraneous solutions, so you just go back and see where's their variable, where can I plug this in. So 14 plus 4 is 18. That's the only place you can plug y in. It's positive, so our answer is good. Okay, let's do this one. So again, we need to condense this. We're going to use the power property. So if I have 1/2 times log base 6 of 25 equals log base 6 of 23 minus 4w, that 1/2 can become an exponent to the 25. Now, anything raised to the 1/2 power, that's the same as taking the square root. So that's the same thing as the square root of 25, which is 5. Okay, now those bases can cancel and you just get 5 equals 23 minus 4w. Subtract the 23 over, you get negative 18 equals negative 4w. Divide by negative 4, and you get w equals 18 over 4, which reduces to 9 over 2. Okay, last thing, we have to check for extraneous solutions. So that's going to be 23 minus 4 times 9/2, and that equals 5, which is positive, so our answer is w equals 9/2. Okay. So that's all for solving logs that have logs on both sides. Now, if they don't, we have to condense and isolate the logarithm, write it in exponential form, and then check for extraneous solutions. We've already been doing this. So when we were finding x-intercepts on graphing logarithms, this is what we were doing. So this should kind of be a little bit of review. So if we have log base 2 of x minus 4 equals 6. Well, the log's already by itself. It's already isolated. So let's change this to an exponent. So that's going to be 2 to the 6 equals x minus 4. Well, 2 to the 6 is 64, so you get 64 equals x minus 4. Add the 4 over, you get x equals 68. Then we just have to check for extraneous solutions, so we plug that in where there's an x, so you get 68 minus 4 equals 64, which is positive, so we're good, and that answer works. Okay, let's do another one. So we have log base 3 of 4x plus 8 minus 7 equals negative 3. Well, we need to isolate that log, so I'm going to add the 7 over. So I get log base 3 of 4x plus 8 equals 4. Change that to an exponential. So that's 3 to the 4th equals 4x plus 8. 3 to the 4th is 81, so 81 equals 4x plus 8. Subtract the 8 over, you get 73 equals 4x. So x equals 73 over 4. Then just double check for extraneous solutions. So 4 times 73/4 plus 8 is 81, which is positive, so we're good. That's our answer. Okay, let's do one more. So we need to isolate, or not isolate this, we need to condense this. And sorry, these have all said A. I'm hoping you're figuring out which one it is. It's like, I think I'm just going down the left side, but I could be wrong. So we need to condense and isolate the logarithm. So those are being added. Addition goes with multiplication. So it's the same thing as log of 2x times x minus 5 equals 2. Well, distribute that in, that's log 2x squared minus 10x equals 2. If it doesn't have a base, it's assumed that the base is 10. So I'm going to write that base as 10, and then I'm going to write it in exponential form. So that's 10 squared equals 2x squared minus 10x. 10 squared is 100. I'm going to set this equal to 0 since I have an x squared and an x in there. Now, first I'm going to check GCF. 2 goes into 2x squared, 10x, and 100. So I'm going to divide everything by 2, and I'm left with x squared minus 5x minus 50. Then I factor that, and I get x minus 10 and x plus 5. Set those both equal to 0, and you get x equals 10 and x equals negative 5. Now I need to plug these in to make sure it works. So when I plug 10 in, I get 2 times 10, which is 20, and 10 minus 5, which is 5, so that works. We're good. And I plug negative 5 in. I get 10 times negative 5 is negative 10. Negative 5 minus 5 is negative 10 also. You can't have a negative, though, so that one does not work. Our only answer is x equals 10. Okay. Now these last ones. So you isolate the exponential equation. You take the logs of both sides. You may need to expand the log using the power rule or something, and then you check for extraneous solutions. So let's get into this. So if you have like 2 to some power equals 61. Well, 2 to any power that we know just off the top of our heads is not 61, right? So we're just going to change this to a logarithm. So that's going to be log base 2 of 61 equals x. Now we can use the change of base formula. So that's log of 61 over log of 2 equals x, which is 5.93 when I round that. Now this is a rounded answer, so it's not going to produce the same exact answer when I plug it back in, but it's going to be close. So I'm going to plug it back in just to make sure it works. So I'm going to plug it in. So 2 to the 5.93 power is 60.9688, and that keeps going. But that is very close to 61, so our answer does work. It is x equals 5.93. And I put the little squiggly equal sign just so we can denote, like, that is not the real answer, but it's really close to it. Okay? Let's do another one. So we have 4 times 7 to the nth power equals 148. We need to get the 7 to the nth power by itself first. So I'm going to divide by 4, and I get 7 to the nth power equals 37. Now change this to a logarithm. So that's log base 7 of 37 equals n. So that's log of 37 divided by log of 7 equals n. So n equals about 1.86. What is happening? Sorry about that. Okay, so n equals about 1.86. Now I'm going to plug it back in, and I'm going to double check it works. I'm going to plug it into the equation that I changed it to. I'm going to plug it into this right here, though, because it's still technically the same equation, and it makes it a little bit easier for me. So I have 7 to the 1.86 power is 37.3149, which is very close to 37, so that works. Okay? Now let's do this one. So I have to isolate the 9 to the v minus 1 power. So I'm going to subtract 1 over, and I get 5 times 9 to the v minus 1 equals 180. Divide by 5. You get 9 to the v minus 1 equals 36. Now change that to a logarithm. So that's log base 9 of 36 equals v minus 1. So that's log of 36 divided by log of 9 equals v minus 1. So that's 1.63 equals v minus 1. Add the 1 over, and you get v equals about 2.63. Then we're going to check it. I'm going to use the one where I changed it to the logarithm to check. So that's 9 to the 2.63 minus 1 power is 35.9265, which is about 36. So we're good. Okay. Remember to take the quiz. I'll see you guys tomorrow. Sorry I got this up late. Bye.